Hi everyone, we are from the Technical University of Cluj-Napoca. My name is Adina and I will present the research that I made with my colleagues Vasile Mărioara, Andor-Nagy and Nicoleta Ilieș. I would like to start by saying that the lack of a good foundation ground layer in some areas that could be used for construction purposes is a common problem all over the world. Based on this, we conducted an experimental study focused on a comparative analysis of the soil mixed with the hydraulic binders Viacalco D and Viacalco S in order to obtain an optimal admixture that could be used for soil stabilizations. From here, the name of our research: soil stabilization with hydraulic binders. Here are the authors and the Technical University of Cluj-Napoca. State of the art. At the basis of this chapter are standing the results of various tests presented in published articles, experimental studies, Romanian regulations, and specialized guides. An article that presented a practical work on the Căpuș River where hydraulic binders were used in order to stabilize the filling material of a riverbank defense and a dam, shows us that by stabilizing the filler material by mixing the local soil with hydraulic binder and water, a significant improvement of the geotechnical parameters was made. Another article published, Applications of Stabilized Soil in Hydraulic Constructions, presents the benefits that the hydraulic binders have on the hydrotechnical constructions and on the environment. By mixing the local material with different types of cement, an increase of the cohesion is obtained, while the internal friction angle remains approximately the same. The deformation modulus and permeability were not affected by the mixture, but this technology has a considerably smaller carbon footprint than the conventional solutions, as most transport processes are avoided in the absence of reinforcement. Freeze-thaw testing of stabilized soil samples used for riverbank consolidation also shows that even the freeze-thaw action of the soil improved with hydraulic binder improves the resistance of a flood defense structure. The aim of the practical experiment carried out during the winter-summer period was to show that one of the binders used has a significant contribute regarding the resistance of the structure. All existing studies show a significant improvement in the bearing capacity of soils based on mixtures with an optimal dosage of hydraulic binder, but we can say that further research is needed to improve this area. Materials and procedures. Materials. Our research was performed on a sandy silty clay mixed with the hydraulic binder Viacalco D and Viacalco S of Carmios, Romania. The soil used for the mixtures was taken for a site near Cluj County, and his composition was determined using the granulometric curve. There were made 56 mixtures containing 2,000 grams of sandy silty clay each, different amounts of water, and a different amount of hydraulic binders that were left to rest for a couple of hours. Each mixture was submitted to the PROCTOR test in order to obtain the optimum moisture content for the soil in natural state and for the soil mixed with the hydraulic binders. After submitting all the mixtures to the PROCTOR test, we obtained 7 mixtures as follows. The first, for the sandy silty clay in its natural state, we obtained an 18% amount of water. For the second, a sandy silty clay plus 2% amount of Viacalco D, we obtained 20% of water. For the third, for the sandy silty clay plus 4% of Viacalco D, we needed 20% amount of water. The fourth, a sandy silty clay plus 6% of Viacalco D, it resulted also 20% amount of water. The fifth, a sandy silty clay plus 2% of Viacalco S, it resulted a 20% amount of water. For the sixth, the sandy silty clay plus 4% Viacalco S, it resulted also 20% amount of water. And for the last one, the sandy silty clay plus 6% of Viacalco S, it resulted 22% of water. After this, we started all over again with the 7 mixtures. We submitted them to the PROCTOR test. We took 3 samples for each mixture corresponding to the SHEAR loads of 100 kilopascal, 200 kilopascal, and 300 kilopascal. After taking 42 samples, they were left to rest. We left 21 samples to rest for 7 days to reach the initial resistance, and the other 21 samples for 28 days to reach the standard resistance. And then they were subjected to the direct SHEAR test, as you can see in this picture. Here we have the results. So, as you can see, from a percentage point of view, there is a significant increase in the cohesion of the soil samples improved with Viacalco D in a proportion of 2%, 4%, and 6%, and with Viacalco S in a proportion of 4% and 6% compared to the soil samples in the natural state. Regarding the residual values, we can observe that for the samples with binder in proportion of 2% subjected to the test after 7 days of rest, the residual cohesion recorded is lower than the residual cohesion of the soil in its natural state. The internal friction angle in all cases registers an increase with the increase of the hydraulic binder percentage, thus obtaining higher values than the internal friction angle for the soil samples in its natural state. And here you can see the results after submitting all the samples to the direct SHEAR test. In the first picture, you can see the results of the samples submitted to the direct SHEAR test after leaving the samples to rest for 7 days. And in the second picture, you can see also the samples that were submitted to the direct SHEAR test, but these were left to rest for 28 days. We also performed an oedometric test to determine the compressibility of the soil in the laboratory, and we followed the settlement of the samples and their evolution in time under the effect of the vertical axial loads applied in steps. Here you have the oedometric equipment with the loads, and here is the progress that was saving. We left a load for 24 hours, and this is what the equipment registered. Here, there are the samples that we took also at the same time when we took the samples for the direct SHEAR test. And the results obtained are as follows. We can observe a significant increase in the oedometric deformation modulus for all types of mixtures compared to the oedometric deformation modulus for the natural soil sample. We also made 2 simulations. One regarding stability of 3 dam sections for whom we chose the dimensions. The composition of 2 sections took into consideration the geotechnical parameters that resulted from the soil mixed with the hydraulic binders Viacalco D and Viacalco S in a percentage of 4%. And for the third section, we used the geotechnical parameters that resulted from the soil without the hydraulic binder. The study was also performed to evaluate and compare the stability of the structure and the costs that are generated. Here we have a video that shows us how the installation of the hydraulic binder must be carried out. The video was made during the experimental study carried out on site at the Căpuș River that we mentioned at the beginning at the state of the art. I will play it on fast forward in order to save some time. So here you can see the base of a dam section and the machine that spreads the hydraulic binder, and it also mixes the hydraulic binder with the superior layer of the soil. I'll play it a little bit faster. Okay. Now you can see the machine that does the compaction of the layer. Basically, the process is just the same. It follows the same steps for each layer. This one is prepared to do just the same, to spread at first the hydraulic binder. Okay. So the slope stability was verified using the GEO5 program, and the study was hypothetical, made to show how hydraulic binder can improve also the stability and reduce the cost by reducing the section size. That's why we obtained exaggerated results that showed a great stability even without adding the hydraulic binder for the type of soil chosen. As you can see here, for the sandy silty clay with 18% amount of water, we had the stability factor equal with 5.13. That's more than acceptable. Here for sandy silty clay plus Viacalco D, 4% plus 20% amount of water for the same section, you can see improvement because the stability factor is equal with 10.07. That's practically double than the first one. For the sandy silty clay plus Viacalco S in amounts of 4% plus 20% water for the same section as well, the stability factor was equal with 6.70, more than acceptable. It is closer for the sandy silty clay with just water without the binder. And you can also see that with Viacalco D, the improvement is better. In any case, the results show a major improvement of the stability factor using especially Viacalco D in the mixture with the soil and the optimum moisture content. As for the economical evaluation that we made, we cannot consider that the cost is a decisional factor in choosing the type of binder that we want to put in place, since the price differences were insignificant. That's why we didn't include it in the presentation. In conclusion, after analyzing the studied soil, the sandy silty clay improved with the hydraulic binder Viacalco D and Viacalco S compared to the soil in its natural state. We can say that the significant improvement of the geotechnical parameters such as internal friction angle, cohesion, and oedometric deformation modulus were made. Also, the residual internal friction angle and residual cohesion had a significant improvement. We also observed an increase of the safety factor on dams. Due to the high values of the safety factor, the dimensions of the sections of the defense structures as dams, for example, can be reduced. And by reducing the size of the sections and replacing the materials needed to be transported on the site with local materials improved with binders, a reduction in investment cost can be achieved. Also, as I was saying, it can reduce also the carbon footprint by reducing the transport because of the reinforcement. And of course, the future research must be made to improve this field. In the end, we would like to thank Armeus Romania for the binders and the technical information provided, and the Technical University of Cluj County, the construction faculty, for all the support, the access granted to the geotechnical laboratory, and for all the equipment that helped us conduct this study. Thank you all for your attention and have a nice day.